Good afternoon, everyone. Thanks for coming to my talk. Hope you've all had a good lunch and are well rested or have more energy to go through the rest of the talks this afternoon. My name is Vatsalya, and today I'll be taking you through a journey in how to automate your DNS in your organization. A bit more about myself. I am a technical lead at Telstra Purple, which is a software consultancy based out of Australia. A bit far away from home, but excited to be here. In my spare time, I'm also a software tinkerer, and I like to just play around with random technologies that come up all the time. So whether that be .NET, Rust, Go, and as well as just DNS, which is a passion of my own. And I like security because not a lot of people talk about how security and software development go hand in hand together. So what does this talk about? Today, we'll go through a few topics. First, we'll talk about DNS being a vulnerable link in any software development or just in your organization altogether. We'll talk about just where DNS came from, what it's about, what it's become now. We'll look at how DNS queries are made across the internet. And then I'll walk you through an approach on how we can manage DNS better in your organizations all across the board. And then we'll leave some time for questions at the very end. So imagine you're a CEO of a large bank. You've been woken up in the middle of the night from a phone call, and you've been notified that your entire online presence has gone down. You can't send mail to other systems, and you can't get in touch because through your traditional systems, whether it be Teams or whether it be any other thing, because the hackers have compromised your entire network. They have access to a lot of customer credentials, and now they redirect all your customers to a fake website that's being loaded instead of the actual backing site. Aside from that, it's even being presented with a proper TLS certificate because obviously if someone has control of your DNS, they also have control of your certificates and can present a proper website. Aside from that, they've also been deployed a malware, and your customers are now vulnerable. This seems like a plot of Mr. Robot episode of someone hacking together, but this actually happened to a Brazilian bank that shall remain unnamed. But in June 2018, this actually happened, and attackers gained access to the bank's DNS services through a compromised supply chain attack. And once they had that, well, they could take over the bank's entire online presence. Didn't matter where they were, they could pass less encrypt checks, they could do domain validation, and that's sort of one very big example of $27 billion of assets being lost or, being compromised because of a DNS supply chain attack. In September 2018, several Middle East websites were hacked for similar reasons, and they were also hijacked due to a DNS supply chain attack. In August of 2013, a Syrian group took down a New York Times, and their target being promote fake news. So this hack could have been much worse, but all they did was try to put cryptocurrency trackers or cryptocurrency miners on the people's website. These are just some examples of DNS being unsecured and can have really large impact on people's day-to-day organizations. 29% of companies use security and event management, but 82% of companies have experienced downtime in the cloud or in-house because of DNS-related issues. 33% of companies in a survey passed DNS information into some sort of security event analysis tool, but only some of them connect and analyze those tools through some sort of machine learning understanding as well. Well, I'm also sure that a lot of you have experienced DNS outages on your own. Can I get a show of hands of how many of you have experienced some sort of DNS-related issue in your work? I see a lot of hands up, which is good. Otherwise, this talk would have been useless. AWS had an issue in 2018, due to which some operational issues led to some DNS outage, and that took down a big portion of the internet. One service. Cloudflare, I'm sure you all know of Cloudflare, had another DNS outage twice, actually, and they took down another half the internet because everything goes to Cloudflare these days. ISPs are another link in DNS where operational issues, someone took down a DNS server and that basically being a single point of failure had outages in August 2020. And I can give you other examples, but Google Cloud DNS and Akamai is another example where we've had this issue. So you can always keep going through this loop of why your website is down. Well, it is always DNS. So let's go back to a time where the internet didn't exist. I know you can't imagine such time, but yes, there was. Some of you might be too young to remember it, including me. I wasn't even born then. The Cold War was on, and the US was trying to compete with Russia in defense and technology. Under Eisenhower, they formed ARPA, Advanced Research Projects Agency. It was a big step in American science, and it was in response to Soviet Union trying to launch Sputnik 1. MIT was working with ARPA on some serious progress with creating a distributed network. And in 1966, ARPANET was born, the first sort of version of the internet. A packet switching network on top of TCP/IP, the protocol. And it was like the internet, but not really, because it was still sort of centralized. In the coming years, as more networks were being built and more people were being added to the network, the scale of the system became too difficult to manage. And this was where things like packet radio was introduced. ARPANET and SATNET were working together, and there was no single way to identify a network with a name. So someone came up with the idea of associating names to an IP address, because no one could remember what IP address was to what endpoint. So this task was given to Paul. Paul and his team had a mission to create a friendlier network where people wouldn't need to remember the IP address of any host. And they first started with something called host.txt. It was very centralized. It was one file. It was about what is this name to what is the IP address. A file like that can be very difficult to manage, and it grew exponentially large, as you can understand. The internet kept growing, and there was a need for a decentralized model. So the DNS was created. Basically distributed. You get to a point where people say what records they want to publish. Someone says, okay, you have the authority to publish those records, and you can accommodate a lot of diverse requirements without having to have a centralized person managing it. So what is DNS now? Well, I like to call it the internet's phone book. It's how we all browse the web. It's what comes down to resolving where you need to go to on the internet. We actually have no estimate on how many records there are these days. The amount of TLDs, amount of hosts being published, the amount of websites being generated, and people adding and removing records all the time. It meant there's no real way to get an accurate estimate. Google publishes a survey saying they handle a trillion queries a day on their OpenDNS service, which means, and Cloudflare and other public DNS providers have similar estimates as well. There are new TLDs being added all the time, and for someone to be able to understand what new TLD to support, what new provider that can manage my domain name, and all of these additional requirements makes DNS very hard to comprehend. And finally, on a bit of a personal note, your domain is your brand. If your organization's domain goes down, your brand is compromised, people keep spamming Twitter, what's happening to your website, and so forth. So it's very important for you to take care of your brand. So how does DNS work? Well, there's 8 steps to it. A user types in an address, example.com. And that example.com is put into your browser, and that is recursively queried to a point where it can be identified to an IP address. So first, it queries the root DNS server. So at the very top of it, there's a list of top-level domains. So .com, .net, .au, .gov, .org, so forth. All of these have authoritative providers. That .com is then resolved to its a new top-level domain, which says, okay, what are the list of domain names that are registered with .com. So it'll look up, okay, example.com. That's my TLD server now. So from root server, I'm coming to TLD server. The TLD server comes back and says, okay, these are the name servers for my address. So example.com resolves to this this name server, and then the recursive resolver queries example.com. It goes back and says, okay, this example.com website is then maps to this IP address. That DNS lookup is done, and the browser then gets the DNS query, and then finally requests the server for the content based on the IP address that's resolved. So we've talked about DNS. We've talked about where we're at and why DNS is important. But let's talk about how unmanaged DNS can cause issues and make things go horribly wrong. Traditionally, within an organization, to request DNS changes, you would have something like a ServiceNow ticket or Zendesk ticket with a form that says, I would like to publish this DNS record. And whether it be removing a record, modifying it, adding it, someone within an IT operations team would go and say, hey, there's this change ticket that's come in. I'll log into my domain system, whether it be a host file or log into AWS DNS or Azure, and make that change. Now, coming from a DevOps world, you can think how big of a no-no that is. Think about it as someone looking at a change ticket and going, okay, I have to copy-paste this address or remove this address, and that can lead to a lot of human error. Well, in the dev world, we created a whole DevOps capability so that you can make it repeatable, you can make it change trackable, and that it's not, you don't have someone manually making changes in your production systems. Making manual changes can be error prone. Copy pasting records, change requests, accidentally deleting records, and no state management means you don't even know what you've deleted correctly. So you don't even know how to roll back properly because you don't have a good record of what was changed or removed. The other one being passwords. Because you have to log into a service, and that service means you need to have a credential, that can lead to credential compromise. A single person would have access to the entire DNS management server. That creates a single point of failure as well. And with LastPass being breached recently, credential compromise is a big point of interest in a lot of organizations these days. So how can we do it differently? Well, let's switch to something we all know about, GitOps. Version control. So using Git, we can obviously, it's been widely adopted, and that any change is tracked, can be easily rolled back to previous versions, and that we have auditability. Automation. We can create pipelines. We can, as pull requests come in or as changes need to be done, we can create a pull request. That pull request can be validated against, and then when people push code to repository, that can be tested, deployed, and obviously pushed to a production environment. Consistency and reproducibility. There's no single person making that change. So anytime that same state is being deployed, you know it's the same change being done. So you don't have something that's different to what your Git repository says. Increase organization productivity. Making changes is as simple as creating a pull request instead of having a change ticket which sits in a queue. Someone has to look into it. Someone has to get to it, wait 5 days, send another email saying, where's my ticket at? I don't know. Oh, sorry, I'll get to it. All right. So that's issues. Enhanced security. As we talked about credential compromise being an issue, you can, instead of using credentials for someone to log in, you use API keys, which scopes down to exactly what change you need to do. You can give control to a particular domain or a particular scope, and that means you don't give keys to kingdom to a single person. Easy rollbacks. Switch to a previous commit or deploy a previous release. And that means your rollback strategy is easy enough. Faster mean time to recovery. Even if someone goes in and manually makes changes, that still means, and if something goes down, You just redeploy, your entire environment is back up. And auditability and observability. Because each commit is tracked, who made the change, who made the request, you can go back and make sure that each request is audited properly. And if an auditor does come, you can go, all right, these are all the changes that we made for my DNS requirement. So how do we do all of this? I am here to introduce a tool called DNS Control. It's actually maintained and built by Stack Overflow, Stack Exchange. It's an open source tool on GitHub, and it's a domain-specific language that is built on top of DNS or to manage multiple providers. So if you have Cloudflare, Azure, AWS, host file or zone files on your local environment, doesn't matter. DNS Control can look after each individual service separately. All you need to know is that domain-specific language for DNS, which is built on top of JavaScript. So if you know JavaScript, you can make DNS changes. We talked about GitOps, so it does source control. You can do CI/CD. It's got a fully robust CLI, which means you can run that CLI on your pipelines, and you don't have anyone locally doing changes. Change tracking, again, Git commits, rollbacks, and API keys rather than username and passwords. So I talked about DNS control being an opinionated tool. So why is it opinionated? First, DNS should be treated as code. So code is written in high-level languages, version controlled, commented, tested, and reviewed by a peer. And all of that happens before it goes to production. DNS information should be stored the same way. Stored in a version control system like Git should receive the benefits of using version control systems. Changes should be in form of PRs and approved by someone other than you. So you cannot approve your own change and push to production. DNS information should be tested for syntax errors, like you would do any other code review. It should pass unit tests and policy requirements, and make sure that it runs an automated CI system that pushes that the same way. Pushing change in production should be effortless, so not requiring people to know which domain or which provider your organization uses. All you need to know is what change you would like to do to make your website go live. The credential updates should be as simple as someone writing a PR as well. But not everyone should have access to credentials. So that makes it very simple. Your secret management tool can manage your credentials, but your code should say what providers to use. Opinion 2. Non-experts should be able to make DNS changes safely. So the goal of DNS control as a tool is to create a system that's set up by DNS experts like yourselves, like us, but the changes can be made by anyone within your organization who aren't DNS experts. Things your coworkers shouldn't have to know. They should not know about obscure DNS technical know-how of, hey, you can't put an SPF record under this domain, or that top-level domains cannot have CNAME aliases, or that anything like that. That level of DNS knowledge should not be the responsibility of people making just changes. Your coworkers should know what to happen when you're in an ambiguous situation. So ambiguity is something like when you make a change of food.example.com, what's to say that it's food.example.com, not food.example.com.example.com, because ambiguity comes in DNS names. So your coworkers should be able to submit PRs. So if it's in a GitHub that your entire organization uses, you should be able to make it available to everyone to use. And once the PR is done, your coworker should even be able to look at what changes you've done by CI, have a preview before it even goes live, so you can understand what's actually going on. And lastly, your coworkers should be able to figure out the language without much training. You should be able to give them just docs on how to make that change without a lot of training required to make that change. And system should itself block them from doing dangerous things, like deleting your entire repo. DNS config, which is the root domain DSL it uses, it's not a zone file. It's a zone file is a list of any DNS records. It has no morals, it has no judgment, and it will let you do any bad practice as long as it is RFC compliant. DNS config.js is a high-level description of your DNS zone. It being high-level allows us to understand intent rather than just definition, and thus allows us to stop bad behavior. And we'll get that into a demo a bit more. DNS is lowercase for all languages that have a concept. So in English, we've got an uppercase A and a lowercase a. In Chinese, not so much. The alphabet is different, but DNS control makes all domain names lowercase if it supports it. And this is because we like to be consistent. You don't type capital F Facebook.com, and that's because they don't resort to two different domains. That's a single domain, and lowercase gives consistency in domain names. Yep, we all know it's insensitive. The DNS itself is case insensitive, but ambiguity is a bad thing, and that's why I see opinion number 3. Users should be able to say what they want, and the tool should take care of the rest. When possible, DNS config lists the change of high-level description, which is desired, and compiler does the hard work for you. Macros and iterators, so being able to write code with loops allows you to do things once and repeat it. Text strings are expressed as JavaScript strings, so allows us to use nice language features in JavaScript to be able to do things, and you don't need to have any weird DNS required escape characters and so forth. Domain names with Unicode, so internationalization and things like Chinese characters, for example, it handles that to pass it into Unicode automatically, so you don't have to worry about any sort of weird case handling either. IP addresses are expressed as IP address, and then it reverts it back to the ARPA internet address, which is how routing happens in IP addresses. And it does the .in address.arpa lookup for you. SPF records, which if you have done emails, SPF records are a way to make sure that your domain is not being spoofed. It's very hard to specify an SPF record in text because it's basically just a TXT record in DNS. There's no specific SPF record types, which makes it hard for you to verbose and provide intent. So DNS control gives you an easy way to manage SPF records as well. We talked about ambiguity. If it's ambiguous, it's forbidden. When there's an ambiguity, an expert knows what to do, but the tool doesn't, because computers are supposed to be deterministic. Actually, nowadays with AI, we don't know what determinism is, but that's a topic for a different time. We would rather DNS control error out than require the user to specify or be DNS experts. For example, as I explained, bar.com or foo.com with a trailing dot is unambiguous. But when you go foo.com without a trailing dot, it becomes ambiguous because we don't know if it's foo.com or just foo.com, which is what your intent was. So it's very hard to understand intent with ambiguous definitions. What about top-level domains? Well, we don't know what the newest top-level domain is. So we don't have to have a list of TLDs to manage. The tool should be able to do that for you, rather than you having to know and specify what that TLD is and make it unambiguous for you. And therefore, any CNAME records, MX records, and name server targets require a trailing dot to unambiguate your DNS record for you. Host names don't have underscores. And I'm not talking about DNS labels, I'm talking about host names in particular, so something that resolves to an address. DNS control gives you warnings when you put underscores in your host names because it's not permitted. If we prevent a naive user from putting an underscore when they're meant to put a hyphen, because hyphens are allowed in domain names, that gives them that check of, hey, this is not what I wanted. I wanted to put a hyphen or an underscore. Yes, labels. So as we said, text record labels and DMARC records, SPF records, those allow underscores, but they aren't host names. They're just DNS labels. And again, because there's no way for us to guess intent, we just specify it as a warning because someone may actually want to put it as an underscore. So let's get to the demo. How am I doing for time? I think I have enough time. Yep. So I have a repository that I maintain my personal DNS zones in. Obviously, I'm not going to make changes to a corporate DNS zone, and I have a few domains that I manage on my own, and I'll be demoing how the tool uses. Yep, I'll zoom in a bit more. That good? Or a bit more? Okay. So it's just a Git repository. If I go ls-la, you can see it's a Git repository with some hidden files. So one's .github, which is my pipelines, .vs code. If I started using Vim, so the VS Code file is redundant, but it's to just make VS Code understand what kind of files there are. And then there's two other folders, DNS control, which is what I'll talk about more, and workers, which is Cloudflare workers that I maintain for myself. So going into the DNS control repo, as you can see the file tree here. So there's this DNS control folder, which has this file called dnsconfig.js. This is your main file. I'll zoom in a bit more. Is that good? So this dnsconfig.js file is what the tool reads to understand what domains you want to manage. And what I've done is I've sort of tried to make it repeatable and manageable by extracting each domain that I look after under its own file in a separate folder called domains. And there's some utils as well. So for example, Cloudflare does this thing called Cloudflare proxy, which allows you to tunnel your request to Cloudflare. And DNS control lets you specify some of those macros. And you can use JavaScript features to basically load them automatically. Things like specifying Office 365 records. So if you have multiple Office 365 records that you manage or domains, you can specify a function that says, OK, I have the domain, I have my identifier, and what's my own Microsoft domain. And then you just basically use JavaScript replace to specify a template of all Office 365 records that you need to manage. Something I do myself is I like to park domains. I don't know if any of you are interested in it, but I like to hold domains and then make sure that no one else has them. For that, I've basically defined a placeholder function with the name, registrar, and provider. And what all it does is basically says no one's allowed to send mail from this domain and reject all DKIM so that no one can send mail or send mail from or send mail to this address. And then there's some DMARC policies, and I'll show you that as well. Yep. And then finally, TTLs, which is just a good a habit to have, is just makes it easy to remember what an hour is, what a minute is, what 1 hour, 1 day is, so forth. And my main file, which is which basically loads these util files and then goes one by one, defining my registrars, my providers. I manage all of them in Cloudflare, but it's got providers for support for Azure DNS, AWS, Akamai, and a whole bunch of others. The website is dnscontrol.com, which you'll be able to find a lot more information on that. As I talked about my global DMARC policy, which says, okay, there's a report URI. I'm not going to go into details of what DMARC is, but it says report any failures of DMARC onto this report URI provider. And then some placeholders, as we talked about, for parking domains. And lastly, these are all the domains that actually have records in them. So going into one by one, I'll actually just open the main one. So this is my main website, and as you can see, there's a few records in there. It's very simple as a definition. So if I wanted to define a CA record, it's basically CA function for my root level domain that points to IODEF and a mail to contact. The same one with DigiCert. If I want to allow DigiCert as an issuer, then I just define that from my root. A records, basically an A with my label and then the IP address and proxy on. MX records the same way, and as you can see, TXT records are basically just providing the label and then the record itself. And this makes it very easy for you to understand what you're looking at. You know what the intent is, you know what it's going to do, what the TTL is, and how you're able to manage it. As we can see, Office 365 records, this is the macro that I talked about, and this basically says this domain uses Office 365, and it points to that Azure Active Directory. Next, I'll go through adding a DNS record and showing you the process of managing your own website in there. So what you have is a CLI. I've got the local dev version built, but this CLI can do a few things. It's got a few commands, preview, which basically does a diff against what you're running in your local repository and the external providers. So it does a comparison and shows you the changes of what you're deploying or what diff there is. Push basically means you want to push the changes that you have locally onto your provider. Check, basically check to make sure you don't have any local errors in your code, which would prevent DNS control from parsing your zone file or your DNS control JS file. IR is the validation logic. It's for us to debug issues if there's anything, the version information, and then some utility functions, which is check creds to make sure that you have the right permissions to make changes. Create domain. This has been deprecated, but it would allow you to create a new domain against the provider. And then some beta types, because I'm using a beta version. Get zone is what you would use to start off with. You basically, what you do is you have this creds.json file, which says what your provider is. So for me, I've got cloudflare.com and name.com, and it's got an API token and account ID. This basically tells DNS control that I have an API, I manage my domains in Cloudflare, and if you want to make any changes, reach out to Cloudflare, which is defined over here. So placeholder, register Cloudflare, DNS Cloudflare. It just basically says, okay, this is where you go to look after my DNS that I want to make changes to. And then what you do is, if you were starting off fresh, you would do get zone, which would read all the records that are there and basically give you a DNS control representation of your records. So you have something to start off with, because you wouldn't want to go to each record, copy it, paste it, build a repository. It's very tedious. It gives you a quick way to build your file out easily. And then once you've got your DNS config.js file, I have a template repository that I'll show at the end of it, which will help you get started. But this is how you would do it. I will. So the next step, what I'll do is I'm actually going to do live DNS changes. Fingers crossed. So I'm going to create a new file. So I've just got this new file here, which is blank at the moment. It's currently one of my park domains here. So I'm just making some DNS changes on the park domain. To do that, I'll just yank the park domains function, or actually I'll copy it from here first. The registrar is Cloudflare and the DNS provider is Cloudflare. Let's remove that, and let's get all of the park domain stuff up. Okay. Just making sure it's all good. So that's just a sample domain file, definition. All I'm saying is I have an SPF that rejects all, and a DKIM to fail, and the DMARC policy. If I make this change onto my pipeline, there shouldn't be any difference, no deployments. So I'm going to and while that's here, I'll actually go into GitHub, my DNS repo, and create a pull request. Even though I manage itself, I just make sure that there's some pull request templates that if you're publishing in your organization, it's good for them to see, okay, have a good template, and I'll zoom in a bit more so people at the back can see. So they've done some prelim checks before they're publishing, and it just gives a good best practice in your org. And just some description. And if there's any tickets or anything like that, and create the pull request. When I create this pull request, there's an action that runs. If I go into actions, and as you can see, this action runs, and it's doing two things. It's making sure that the change that I've done is correct, and there's no issues, and that it does a preview of the changes that will be deploying. So the check passed, no issues, and then preview. And as you can see, I basically just copy pasted what was there, so there are no changes. Which now, let's add some changes. I would like to add a CNAME record to NDC. And I would like to point that to a record that I don't have yet. And let's get that record. Make sure no syntax errors. And actually, I made a different issue, which I would have caught if I remembered, which is it's still copying as placeholder. So even though I added that file, it didn't make any changes because that domain itself was as a placeholder, not included as a proper domain requirement. So let's just actually do that. So it's made two changes to DNS config and changes to Vatsalya tech, which, and just to make sure that the changes are correct, I'll actually go here. It's added that, which means it's going to read it from this file, and I've added my CNAME. And as you can see, making changes and running the check, it's very quick. It within a minute, you know what exact changes are happening. If I go back to my actions again, and you'll see this actually fails because I intentionally put an error in there, which I wanted to demonstrate as the failure path of what happens if someone does a mistake. So what's the check? This should end with a dot. The ambiguity issue as to, well, yeah, you can't have a CNAME that's ambiguous or a hostname that's ambiguous. So let's fix that. All I needed was to add this last dot. And make sure that the change is just that. Yep, just adding the last dot there. And that, third time's a charm. Should hopefully pass and give me a list of changes. So at the moment, all that ngrok endpoint is doing is serving a file of my local, sorry, not that tunnel. Yeah, okay. So all that ngrok endpoint is doing is serving a static HTTP or static HTML file from my local. And if I go right now to it's just a localhost file. But if I go to that DNS domain name doesn't exist. And if the demo gods are with me, all I need to do is, and I'll actually get all of you to do this because there's this QR code, which is that domain. So if you want to scan it and see that domain doesn't work and I'm not doing some local voodoo, all right. So let's merge this pull request. And while it's merging, I actually forgot to show you the preview, which is what I love about this tool. Or last one here, domain Vatsalya tech, which is the domain I wanted to change. One correction, create a CNAME record for NDC to this host name. And I should zoom in a bit more. And that's what someone in your ops team would run and check to make sure any records that's been changed is actually what's been applied. And it gives you a very good way to correct domain changes. And if I remove that line, the next time I'll actually remove that DNS record. And we'll do that once the site is up. That's merged. And deploy. So the deploy is complete. And we said that this website wasn't up, and still not up. DNS control push. Let's go to ndc.vatsalya.tech, which is created here. And that's why you don't want to do DNS changes on live. But I will see what's happening here. Sorry. All right, let's try to actually do an NS lookup as well. Okay, that server is up. So let's try that again. No. That domain is definitely up. Maybe the host name has changed. That's working. And maybe my TTL is down. Could not connect to server.
Can you zoom in?
Yes.
No, the URL. I'm trying to see if I can reach it from mine.
It worked?
Trying to load DNS cache.
All right. Yeah, probably just my laptop being DNS cached, which, yeah, that's the QR code. So I guess it doesn't work on a local machine, it works on everyone else's. So with that partially failed and partially succeeded demo, let's try and remove the domain name back and take the site back down again. All I need to do is delete that file. And I actually need to switch to main. And obviously do as I say, not as I do. And push to main as always. Which is going back. It removes it, and if I go into Cloudflare, that should hopefully remove in a couple of minutes. So what did we learn from this demo? Well, never make live changes in DNS in a conference, but more broadly, you have a good way to make repeatable changes in your organization without having to have someone technical make DNS changes for you. It's simply a Git repository that you can create a pull request against. What I have done for this group is created a template repository that has the actions in there and has sample DNS config files which you can use and just get started without having to run through a lot of docs reading. I do have, I'm not going to go into this a lot more, but like DNS control, if you're using Kubernetes, there's a separate tool which does very similar things called Kubernetes External DNS. If you do like to manage Kubernetes clusters, this is a really good tool. I'm not going to demo it, but it's a good one to remember for if you want to use it. And that brings me to the end of talk and questions.
Can something like this be done with something like Terraform? If team already is using Terraform for other things, maybe it's possible we can use.
So we don't have a Terraform provider. Terraform does like to manage DNS with some cloud providers. So if you've got Azure, AWS, or Google Cloud, Terraform has its own implementation of their DNS providers. So those three in particular, yes. But I'm not sure about anything else. DNS control, the thing with DNS control itself, it's provider agnostic. It's got a good language to manage multiple providers rather than just a few cloud providers that Terraform manages. I think you had a hand.
Yeah, so are there any tools for managing Let's Encrypt?
Yes, so actually, if I go back into the CLI tool, so it does some cert management, not fully, but it does issue certificate via Let's Encrypt. So you can get certs and manage certs via DNS control as well. I think you had your hand up as well.
Yes. I was wondering how provider agnostic the tool actually is, because I would assume they need some kind of API from the provider, and for example in Norway we have a smaller provider called DNS. So I'd be curious if like small stuff like that was supported, and where the support comes from.
So the question was how provider agnostic the tool actually is. And I'll actually answer this by going into the repository itself. So this tool itself is written in Go. And let me zoom in again. And what it does is it gives you a provider agnostic way to implement it. So if there's a provider that you have that you don't find on there, you can actually create a pull request to add that provider support for yourself, as long as the provider gives you an API. So I did that for Azure DNS myself because this tool didn't support Azure DNS in the start, and I created a pull request for it. But the tools that it does support, the domains management that it does support, it's quite a big, decent link here, or list here. And sorry, what was the provider name that you said?
It's a domain name shop. It's actually on there.
Oh.
Pretty cool.
So, yep.
It's not on GitHub, but I checked on the website in list of providers. Some of them marked as official, and some are unofficial. What does it mean?
It just means the maintainers are active. So, and the DNS controlled Stack Exchange has actual integration tests running against those providers. Obviously, because Stack Exchange can't maintain test DNS for every single registrar and provider, DNS control has a set list of providers that it runs tests against all the time, and the other ones, it expects the maintainers to be able to run those tests against them. Any other questions? If not, thank you very much for coming to my talk, and I hope you have a great NDC Sydney.